to today's lecture. Today we want to look at the Gauss-Jordan method for solving a system of equations. Gauss-Jordan method for solving a system of equations. Now this method is not very different from the last method I taught you, the Gaussian elimination method. There's a slight difference between this one and the Gaussian elimination method. Now, to understand this method, let's look at a question. In the course of solving a question, all the concepts you need to know to understand this topic or this method will be given to you. Now, let's look at the question we solved when I was teaching you the Gaussian elimination method. A plus B plus C is equal to 3. A plus 2B plus 3C is equal to 4. And then A plus 4B plus 9C is equal to 6. Now let's look at how you can use the Gauss-Jordan method to solve this. Now, first of all, you have to get the matrix. So, first of all, solution. The matrix will be like this. You write the coefficients as usual. So, you are going to have 1, 1, 1. And then this one will be 1, 2, 3. You are looking at the coefficients. The third one, 1, 4, 9. And then this one will be A, B, C equal to 3, 4, 6. So you think that the system is like this and equal to B. I see. So this is it. And those of you who have not watched the video on Gaussian elimination, you can look at it. You can look at that one. And you can, before looking at this, that one is not different from this. There's a slight difference between this one and that one. So you have it this way. Now, having obtained this, then you just come, you write your augmented matrix. So 1, 1, 1, 1, 2, 3, 1, 4, 9. The augmented matrix, as I explained to you last time, this is how you write it. Like this. Now, this one, for this method, this is what we are going to do. We are going to cause this to go to 0, this to go to 0, this to also go to 0, this one to go to 0, this to go to 0, and this to be 1. In other words, we are going to cause the left-hand side here to be the identity matrix. The identity matrix, or the identity matrix. That is 1, 0, 0, 0, 1, 0, 0, 0, 1. If you're able to transform this one into the identity matrix, whatever will be on the right hand side will be the solution to the system of equations. Now, if you're able to transform the left hand side into the identity matrix, what we also say is that the problem, the left hand side has been transformed into reduced row echelon form. Reduced row echelon form. So when we are doing the Gaussian elimination, I told you that when you're able to reduce it, that one, these will not be zeros. Yes, and that one, I told you that one was row echelon form. But this one is reduced row echelon form. It means that this one is an identity matrix. If you're able to do this, all these are zeros, these are 1 over, these are zeros. Yes. Okay, so let's do that. So we are going to work on the left hand side here so that we obtain an identity matrix. Now, how do you do this? So let's look at the operations. You are using the normal elementary row operations. So I'm going to have something like this. Row 2 minus row 1 should give us row 2. Because you want to cause this one to go to 0. Normally it's advisable to call this one to go to 0. You come here and get to this one. So let's do that. Now, we can also do this. Row 3 minus row 1. This one will give us row 3. Okay, so let's perform the operations, the elementary row operations. Now, row 1 has will not be typed. So this, now row 2. We are saying that row 2, to get row 2, we subtract row 1 from row 2. So when you subtract 1 from this, you are getting 0. 1 from 2, you are getting 1. 1 from 3, you are getting 2. 3 from 4, you are getting 1. Now to get row 3, you are saying that if you subtract row 1 from it. So 1 minus 1 is 0. 4 minus 1 is 3. 9 minus 1 is 8. 6 minus 3 is 3. So you have it this way. So you see that I'm going to change this one to 0, this one to 0. So 0, 0. Now let's go and work on this one. You want to change this one also to 0. And write this one over there. Now, so how do you change this one to 0? You can say that row 3 minus 2, 3 row 2. You see, if you multiply this one by 3 and subtract from this, it will go to 0. So row 3 minus 3 row 2 should give you row 3. Yes, so let's perform this elementary row operation. 1, 1, 1, and then 0, 1, 2, 1. Now let's move on to row 3, where you have to perform the elementary row operation. Row 3, we are saying that row 3, that here is 0 minus 3 times 0. Isn't it? So it is 0 minus 3 times 0. So this one will go to 0. The next one, 3 minus 3 times 1. 3 minus 3, that is also 0. And then the next one, 8 minus 3 times 2. 8 minus 6, and that is 2. Then the last one, 3 minus 3 times 1. Isn't it? 3 minus 3, which is 0. So you have it this way. So you have been able to cause this one also to 0, to go to 0. Now, let me clean this side, but and continue. Now, look on the board. Look on the board. You want to call this one, these two, to go to 1. So that we have 1, 1, 1. Don't forget, you want to reduce the left hand side to the 1, 0, 0, 0, 1, 0, 0, 0, 1. To the identity matrix. You want to transform this one to the identity matrix or into the identity matrix. So it means that R3 divided by 2 and 1 over 2 times R3 should give us R3. It means that we are dividing through row 3 by 2 to make this one 1, to cause the 2 to be 1. So when you do that, you are going to have something like this. 1, 1, 1, because the first row has not been typed. You are not performing any row operation there. The second one too, you are not performing any row operation there. Now, the last row, we are dividing through the entire row by 2. 0 divided by 2, 0. This one divided by 2. This one divided by 2, give us 1. Divided by 2, give us 7. So you have it this way. So look on the board. You see that we have 1, 1, 1. So it means that what we have to do is to change this one to 0, this one to 0, this one also to 0. So how do you do this? Now look on the board. look on the board. You can say row 1. To cause this one to 0, you can just say that, you can say row 1 minus row 3. No, if you do that, this one will still be there. So, well, okay, why don't we change this one? You can change this one to 0, this one to 0. Okay, so row 1 minus row 2. Row 1 minus row 2. Yes, if you do that, this one will go to 0. Let's do it gradually. This one will go to 0. We are going to have something like this. So, row 1 minus row 2. Yes. Now, let's perform this. This one will give us row 1. Let's perform this one. If you perform this operation, you are going to have 1. That is 1. This one. Okay, let me repeat. Let me repeat the ones that are not going to touch. 0, 1, 2, 1. That is the second row. And then 0, 0, 1, 0. Now, row 1, we are saying minus row 2. So this one will be 1. 1 minus row 2. This one will be 0. 1 minus row 2. This one will be negative 1. And then 3 minus row 2. This one. So this one will be 2. Isn't it? Now, you have been able to change. This is 1, 1, 1, 0, 0, 0, 0. So this one should be able to go to 0. This one should go to 0. And then this one should also go to 0. Now look on the board. You can say that to cause this one to go to 0, to cause this one to go to 0, you can say that row 1 plus row 3. You see, when you add these two and put here, you are going to get 0. So row 1 plus row 3 should give us row 1. Let me continue from this side. If you have already written this, so let me just doing this one and continue from here. So row 1 plus row 3, and we are putting at row 1. So let me repeat. 0, 1, 2, that's row 2. I'm writing the numbers in row 2. And then this is 0, 0, 1, 0. Now let's move on to row 1. You see, to get to 1, you are adding row 1 and then 2. And row 3. So 1 plus 0, 1. 0 plus 0, 0. Negative 1 plus 1, 0. And then 0 plus 2 plus 0, 2. So have it this way. Now, we are almost done. You should be able to cause this one to go to 0. You're able to cause this one to go to 0. Whatever will be left here will be the final answers. So how do you do that? You can say that row 2 minus 2 row 3. Look at this one. You can multiply this one by 2 and subtract from this. So when you take a decision, it should affect the entire rows. So this one will give us row 2. So this is going to give us this. Look on the board. We are not touching row 1, so let me repeat the numbers there. And then we are not touching row 3, so let me write the numbers there. Now row 2. You see, you are saying that row 2, here, 0 minus 2 times 0. This one will be 0. Isn't it? 0 minus 2 times 0. Now 1 minus 2 times 0. This one will be 1. Then when you come here, 2 minus 2 times 1. This one will be 0. That will be 2 minus 2. And then 1 minus 2 times 0. And this one will be 1. So, viewers, we have seen that we have been able to reduce the left-hand side. We have been able to transform the left-hand side into an identity matrix. Look at it. 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, when we're able to do this, we also say that the left-hand side has been transformed into a reduced row echelon form. And then when you are able to do this, then straight away, whatever you have on the right-hand side will be the solutions to the problem, will be the answers to the problem. So this implies that A is equal to 2, B is equal to 1, and then C is equal to, and C is equal to 0 in that order. We have A, B, C, isn't it? So this is basically what the Gauss-Jordan method is about. You try to write the matrix in augmented form. That is the matrix you are getting from the problem. And then you fill that one with the right-hand side values. And then try to work on it until you see that you are getting an identity matrix on the left-hand side. If you are able to get an identity matrix on the left-hand side, then whatever you have on the right-hand side will be the solution to the problem. So this is what the Gauss-Jordan method is about. It's not difficult at all. For more of this video, please subscribe to my YouTube channel, Shamalaa Jnr. Thank you very much for your attention.